Good morning, all. Welcome back to session number 5. So, in this session, we are going to discuss about tidal power plant as well as the wave power energy. So, these are the two different topics we are going to discuss about in this particular session. So, this is the table of content. It includes the introduction part about tidal energy along with wave energy, and we are going to discuss about the conversion process also. I mean, how we are converting the tidal energy or wave energy from one form to another form. I mean, the tidal energy to how we are generating electricity. In similar manner, from wave energy to generation of electricity. These things we are going to discuss. Along with that, the fundamental characteristics of tidal power plant as well as the wave energy, and finally the limitations of the tidal energy. So these are the few important topics we are going to cover in today's session. So first, coming to this slide, first we'll try to understand about tides and waves. I mean, how we are getting tides as well as waves, then how we can convert these tides and waves to the available kinetic energy into electric energy. Those things we'll try to understand. So basically, the water in the ocean is continuously in the motion due to the wave as well as the tides. And the energy can be converted by using these kind of motions. Okay. First, we'll pick a wave. So wave is nothing but it is driven by the winds. Normally, these waves are driven by the winds and make the water oscillate in roughly circular orbit. Okay, so and the depth is normally it's varies with respect to the season also, and normal wavelength is nothing but it's one of the wavelength. Okay, so this is nothing but the wave energy. Similarly, the tides. Okay, so these tide energy or the tides, basically the tides are related to the gravitational pull of moon and sun of the oceans. Okay, and the wavelength, basically we are having very high wavelength compared to wave energy, especially in the tidal wave energy. And due to that waves, right, higher the tides and lower tides, we are concentrating on both the tides. By using those two tides, we are converting the kinetic energy of the water into electric energy. So this is the basic working principle with respect to the tidal as well as the wave energy. So coming to this slide, here we will discuss some characteristics of the wave energy. Okay, and these characteristics are nothing but the significant height of wave. Okay, so with respect to wave energy, right, the height of wave, it will play a very important role. Okay, because most of the kinetic energy, part of the potential energy, right, we can extract from this kind of height of the waves. Okay, and the period of that particular significant wave means the period also matters. Means how, with respect to the duration, for how long we are getting same kind of wave with respect to that particular height. And third one is nothing but the energy, right? The energy level with respect to that particular wave and the density level with respect to that particular level. Okay, and the power of that power density of the particular wave. Okay, and finally the power, whatever the power we are extracting on, whatever the power we are producing, that with respect to per unit width. Okay, so these are the basic characteristics we need to concentrate to while converting the wave energy to electric energy. So here we can see some basic difference between the tidal energy as well as the wave energy. Okay, so we know that, right, the tidal energy basically depends on the rise and fall of the sea levels, but whereas the wave energy basically depends, or we can convert from the waves moving along the surface of the ocean. Okay, and second point, the tidal energy, right, this basically depends on the gravitational pull of the moon as well as the sun on the earth, but whereas the wave energy, it is basically due to wind. Okay, So then the intensity is affected by location as well as the position of the earth with respect to tidal energy. But whereas in the wave energy, right, the intensity is affected by only the wind strength, how much the wind is having strength, basically that will decide the intensity, okay, with respect to the wave energy. Then the types of tidal energy include kinetic as well as the potential energy also in terms of tidal energy. But whereas in the wave energy, right, the type of wave energy include only the kinetic energy. So this is the basic difference between tidal energy as well as wave energy, okay. And normally in the tidal energy, we'll face some discontinuous source of energy that is generated for about 6 to 12 hours at a time. But when you compare this with the wave energy, the continuous source of energy, you can expect the source continuously in terms of wave energy. So next point is nothing but, so the especially the tidal energy, right? It can disturb the migrating routes of birds as well as the boarding pathways. Basically, it will result in a large amount of it will spoil the species. Okay, but the wave energy, right? The effect on surrounding environment with respect to ecosystem and other communities, right, is very low compared to the tidal energy. And construction cost, right, when you compare with the tidal energy, high construction cost, but low maintenance required, whereas in the tidal energy, okay. But in case of wave energy, extremely high startup costs and design to develop the technology required, right, for the installation of wave power plant or wave energy power plant, right, the higher technology is required. So for that, we need to invest much money. So this is the basic difference between tidal energy as well as the wave energy. Okay, so now we'll discuss on how we are converting that wave energy into electric energy, or how we are converting that tidal energy into wave energy with respect to line diagrams. Okay, so here in this slide, first we will discuss about the wave energy conversion, right? By using how we can convert the wave energy into electricity by using this machine. Okay, so you can see this is the line diagram, or you can say it's a schematic of the wave energy conversion machine. And the basic components are like check valves. I mean, we have two different check valves. One is with respect to inlet, and another one is with respect to outlet. Okay, so atmospheric air will enter through inlet check valve to the piston. You can see here we have piston cylinder arrangement along with the square flow. Okay, so these are the tanks, or these are used for multi-purpose, right? The buoyancy and the air storage tank, and this is the compressed air what we are sending to the turbine to generate electricity. And these are the few important and four vertical, these kind of vertical manifolds, totally four vertical manifolds will get in this kind of setup. Okay, so this is about the component of wave energy conversion machines. So now we'll discuss about the working principle, basic working principle of this wave energy conversion machine. Okay, so we know that. So this is the cylinder and piston arrangement along with the square float, and these things are attached to the four vertical manifold. Those manifold are connected to the storage tanks. Okay, so coming to the working principle of this wave energy conversion machine, the downward motion of the piston draws air into the cylinder via inlet check valve. Okay, when the piston moves downward, right? So whatever the atmospheric air is available, that atmospheric air is we are sending to the piston, I mean the cylinder, through the inlet check valve. Okay, and the upward motion compresses the air. You know that, right? When the piston moves from upward direction, whatever the air accumulated inside the cylinder, that will be get compressed. Okay, and after compressing, right, the air, and it can be sent through the outlet check valve to the these storage tanks. Okay, from these storage tank, how we are sending means from the cylinder through the vertical manifolds, right? You can see this is the passage provided for the compressed air. You can send to the tanks. Okay, this is one part and this is another part. Like that, we have four different vertical manifolds. By using those vertical manifold, we can send the whatever the compressed air inside the cylinder, that can be sent to the buoyance on the air storage tank. Okay, from these air storage tank, then we can directly send these compressed air to the turbine, so that the turbine is coupled with the generator, so that we can convert the kinetic energy of kinetic energy into the mechanical energy. Then whatever the available mechanical energy is there, that will be converted into electrical energy with the help of the generator. So this is the basic working principle of the wave energy conversion machine. Then, so coming to this slide here, we will discuss about the tidal power plant. So basically, the tidal power plant classified into two types, depending on the type of basin. So those are nothing but single basin tidal power plant and the double basin tidal power plant. So first we'll pick the single basin tidal power plant. So in this slide, you can see the schematic representation of single basin tidal power plant. These are the few important components like STG, like hydraulic turbine generator. Along the dam, this is the barrier, this is the basin, right? This is the sea level. So here, or you can say in the single basin tidal power plant, right? It's very difficult to generate power continuously. This is the one of the main drawback of the single basin tidal power plant. Okay. So in these kind of power plants, the pumped storage capacity may be incorporated to fill the water to a high level, okay, and empty of the basin to a lower level, okay. And the pumped storage plant is useful when the load supplies the fluctuate considerably. When there is a much fluctuation, right, at that time, these kind of power plants are very much necessary. Then coming to the working of this single basin tidal power plant. So you can see right here we have the basin. So the basin is filled during the high tide by opening the gates in the barrage. So this is the gate barrage, right? Along with the powerhouse, it consists the turbine along with the generator, okay? And the water level in the basin reaches the breast level of the tide. Then we can the energy is stored in the form of tidal range, okay? Then the tidal range gives the head of, you can expect the higher head level during the this kind of high tides, okay? Then initially during the low tide, the level in the basin, right, is almost zero, okay? Then water is released during the generating mode, right, through the turbines, so that the kinetic energy of the water can be converted into mechanical energy. Then whatever the mechanical energy is converted, that mechanical energy is converted into electrical energy with the help of generator. So this is the basic working principle of the single basin tidal power plant, okay? So next, coming to double basin power plant. So basically the double basin power plants are classified into two different types, okay, based on the setup, okay. First one is nothing but the double basin linked basin tidal power plant, and second one is double basin paired basin tidal power plants. So we'll discuss the basic working principle of these two types. First, we'll pick the linked based tidal power plant, okay. So here you can see the geometry, right? So here we have two different basins or reservoirs, you can say. This is nothing but upper basin, the lower basin. These two basins are separated by the barriers that includes the power plant, I mean the turbine along with the generator. Okay, these are the slowest gate inlet, and this is the outlet, this is the dam. Okay, these are the two slowest gate. One is with respect to inlet, another one is with respect to outlet. So inlet, at the high tide, the water will enter into the upper basin, and during the low tide, the water will enter from lower basin to the sea through the outlet sluice. So this is the basic arrangement or basic representation of the double basin linked basin tidal power plant. Okay, so coming to working principle, basic working principle of this type. So basically the high basin gets periodically filled during every high tide, okay, from ocean through the slice, I mean this inlet slice. Then the low basin, right, it gets periodically emptied by flow to the ocean through the slides during the low tide. I mean, this is the low tide. Okay. Then the turbine generator setup, whatever the turbine generator setup we have placed here or installed, right, in the barrier. Okay. The water flows from high basin to low basin through this STG or this power plant. Okay. The kinetic energy of the water is converted into mechanical energy. Then the mechanical, whatever the available mechanical energy is there, that thing will be converted into electrical energy with the help of this power plant. Okay. And the flow is controlled in such a manner that the continuous power is obtained, right? We can expect the continuous power generation by using this kind of configuration or by using this kind of setup. So this is the basic working principle of the double basin tidal power plant. Okay, I mean double basin linked basin type power plant. So next one is double basin paired tidal power plant. Okay, so here you can see the schematic representation. Here also we have two different basins like high basin and lower basin. But you can see here, this is the inlet, this is the inlet or this is the inlet gate, and this is the outlet gate. With respect to these two basins, I mean the higher basin or lower basin, we have two different turbines. Okay, so this is the difference between the linked basin tidal power plant and paired basin tidal power with respect to construction wise I'm telling you. Okay, these are the basic difference between these two power plants. Okay, coming to the working principle. So during high tide, high basin is filled by the water, and during low tide, the high basin discharged via turbine. Okay, so at that time we can convert one form of energy into another form of energy. That is nothing but kinetic energy of water into the mechanical energy. Okay, then again during high tide, low basins are filled via turbine, and during low tide, low basins is sliced via lower turbine. This is the basic working principle of the double basin tidal power plant. I mean double basin paired tidal power plant. Okay, so here we have some advantages and disadvantages of tidal power plant. Okay, first we'll discuss advantages. So coming to advantages, first point is it is pollution free. So here, while converting one form of energy into another form, we are not using any fossil fuels. So that's why you can say it's pollution free. And whatever the energy we are using as an input during the conversion process, so that is freely available. So next third one is power available around the year. So you can generate the power throughout the year. Okay, and it is unaffected by the unpredictable monsoon, right? So you don't have any major impact from the monsoon on tidal power plant. So these are the few important advantages with respect to the tidal power plant or tidal power generation. Okay, similarly we have some disadvantages also. So first disadvantage is nothing but the capital cost of the plant is high, it's long construction time, right? So so for setup it required more time as well as the high capital investment. That is the drawback of the tidal power plant. And the components, whatever the component we are using, especially with respect to the tidal power plant, those components are having very lower life, right? Because those are exposed to water and corrosive in nature. Okay, so because of that thing, the component will lose their life quickly. So periodically we need to change those kind of components. So for that, again, there is a investment is required. Okay, that is also one drawback. Then the construction of tidal barrage or dams, right? Those things are especially required advanced or higher technologies. Okay, so to achieve those kind of technology, again, there is a complex design actually in those kind of technology. To overcome of those complex problems or the drawbacks, right? The advanced technology is required. So that is also one kind of disadvantage. Then the tidal power output is not constant throughout the day. Okay, so we can maintain throughout the day as a constant, but for that pumping is required. So without pumping, right, it's very difficult to maintain constant throughout the day. Okay, Then the sedimentation of basins is a major problem, and seawater is, that is very corrosive in nature. That will spoil the component, whatever the major component, including the turbine blades, right? Those will impact on the life of the component. Okay, these are the few important advantages as well as disadvantages with respect to the tidal power plant. So here we have some MCQs with respect to session number 5. So the first question is, so tidal power is renewable because the options are tide falls and rise without fuel, and second option is tide falls and rises with fuel, and third option is tide neither falls nor rises without fuel, and last one is tide neither falls or nor rises with the fuel. But the right option, the right answer is tidal falls. Tide falls and tide rises without fuel, right? We are getting both the patterns, I mean high tide as well as the low tide, whatever we are getting those pattern. So that pattern we are achieving without fuel. So that's why we can say it's the renewable. Okay. So similarly, we have second question. How many high tides occur every day? Okay. So options are 1, 2, 4, 3. Okay. But the right answer is 2. Okay. So normally we get 2 high tides with respect to 1 day. Okay. I mean with respect to 24 hours. And the third question is, what is a tide mill? Okay, so definition of tide mill, and the options are a dam to store the tide, and second option is the water mill driven by the tidal rise and fall, and third option is a barrage, and last option is a lagoon. Okay, and the right option is a water mill driven by the tidal rise and fall. Okay, so basically the mill of the power plant which is driven by the high tide as well as the low tide. Okay, question number 4. Both horizontal and vertical turbines are used to harness or convert energy from farm. Okay, so whether it's true or false. Okay, it's true. We require both horizontal as well as the vertical turbine to obtain the energy form. Okay, and last question, what is dynamic tidal power? Okay, options are the theoretical technology exploiting potential energy of tides, and second option is the theoretical technology exploiting potential and kinetic energy of tides. Third option is the practical technology exploiting kinetic as well as the potential energy of tides. Last option is a practical technology exploiting thermal energy of the tides. But the right answer is second and B. Okay, it's nothing but a theoretical technology which we are using to exploiting the potential and kinetic energy of the tides. I mean, it includes both high tide as well as the low tides. So these are the important MCQs with respect to this particular session. Okay, so these are the frequently asked question and the difference between wave and tide. And with the schematic, we need to explain the working of the wave energy conversion. Similarly, with respect to single basin tidal power plant with schematic and double basin power plant with schematic. And last question is related to the advantages and disadvantages of the tidal powers. Okay, so this is the outcome of this particular session. So tides, we should know the definition and the importance of the tide and waves, generation of tide and waves, and the difference between tide and waves, and the energy production from the waves, right? So how we can convert the energy from waves into the electricity, right? That process, and along with the tidal energy also, how we can generate electricity by using tidal energy with respect to both high tide as well as the low tide, and similarly the advantages and disadvantages of the tidal power plants. Okay, this is the outcome of this particular session. Okay, so these are the few important references which we consider for this particular session. So with this slide, I'm going to wind up today's session. So we'll meet in next session, that is nothing but session number 6. Thank you.